Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK 2024 exam is approaching. We have started a series where we are discussing all the top 30 questions from very high weightage topics. So in this video, I'll be discussing the top 30 questions from the organic chapter, that is hydrocarbons, right? So it is a medium weightage chapter where you can expect like 2 to 3 questions from this chapter. So it is like basic chapter because it shows about all the types of reactions, reagents, electrophiles, nucleophiles, right? So very basic chapter. So but the questions here asked are quite easy and a scoring topic. So let us see the first question here. And I can say, like, if these are all like questions are from previous year papers also. So if you are able to solve these questions, you can assure that you can like score out of 3 questions. You can easily be able to solve like 2 questions from this chapter correctly. Okay. So let us see the first question. So the first question is, the alkene on ozonolysis yields acetone only is. Okay. So you have to find which alkene on ozonolysis will give you acetone as the major product. Okay. So if you know any double bond is there, when you treat it with ozone, this bond breaks and we get here oxygen and here oxygen, right? Now if you see, we need acetone. So acetone structure is like this. This is double bond O. So whenever you want to find the alkene from the acetone or from the product, so what you have to do is, the trick is you have to keep both the oxygen together and then remove the oxygen and join it with double bond. For example, the question here is, it yields only acetone, means both the products, where whenever ozonolysis will happen, we will get minimum 2 products, right? Because the alkene has to break. So that means 2 acetones are formed. So if I do like this here, we'll get here 1 acetone and here 1 acetone, right? Now what we will do is, we will remove this oxygen and then connect it with double bond. So we will get this one. Now which compound is this one? So you can see option number C. So correct answer for this question will be C. Now next question, in the reaction, you have to find the major product. Okay, so this one is again a very good question. You have like this and we have OH here. So when there is H plus, so this one will be protonated and then this one will leave and we will get a carbocation here, right? Now if you see, this is a 4-membered ring, so there can be a ring expansion because 4-membered rings are strained molecules. So what will happen, this bond will go here. Now I will number it 1, 2, 3, 4 and 5. So now when this bond breaks here, the positive charge will come on the second carbon now and we are getting a 5-membered ring. So we can do a 5-membered ring here. Okay, so I'll do 1, 2, 3, 4 and 5. So the positive charge is on now second carbon and on the first carbon we have 2 methyl groups. Now what happens, this bond, okay, this bond shifts here because this is a secondary carbocation. Now if one bond shifts here, we will get a tertiary carbocation. So there is a rearrangement here. So what will happen, this bond shifts here. So we will get this one, okay, and here and here, and then one, this is positive charge, which is a tertiary carbocation. Now what happens, this is hydrogen is present. So this bond can shift here to there will be deprotonation and the final product we'll be getting is this one. Okay. So the correct answer for this question will be option number D. Okay. Next question, the mechanism of the reaction in terms of intermediates or type of the reaction is given below. Mark the incorrect option. Okay. So now if you see the first one, HBr, okay. So in HBr, that when you add only HBr, the carbocation intermediate is formed and the most stable intermediate or carbocation will take the Br minus. So this is correct. Now if you see HBr with peroxide, it undergoes through free radical mechanism. Now if you see this one, when you have this group double bond, okay, and you are having X2, so this is addition reaction. Okay, this is addition reaction, but here it is given electrophilic substitution reaction. So this is incorrect. Correct answer for this question will be option number C. Okay, next, the most acidic hydrogen atoms are present in. So we know ethyne, alkyne hydrogens are more acidic. Why? Because if you have, when this H goes out, we will get a negative charge here, and since sp carbons are highly electronegative, the negative charge is stable here. So more acidic will be your ethyne. Correct answer is option number C. Next, complete the following reactions and select the correct option. Okay, so now if you see here, phenol to benzene, that is with zinc dust. So you can see we can eliminate option number A and we can eliminate option number C. Okay, so B is also having zinc, D is also having zinc. Now if you see SO3H and you have with what it will give you again benzene. So if you know with sulfonic acid with water will give you benzene, right? So option number B is also having water, this is also having water, but it should be water with steam. Okay, you can see the temperature 150 to 200 degrees Celsius, so water will be in the steam form. So correct answer for, like, we can see this one, option number B. Now the last one, if you see, it is hydride ion with nickel aluminium ion. This one also can produce benzene. So correct answer for this question will be option number B. Next, okay, the reaction of this one we have to with HBr we have to do. So if I draw this reactant, we have CH3, CH, double bond, CH, then this one, and then OH. Okay. So now you see benzyl carbocations are very stable. So what happens when this bond will break? Okay, you have to give one side positive and one side negative. So this one should be positive, this one should be negative, because this carbocation is resonance stabilized. Now if in HBr you can see what is there, minus plus is there. So we can take minus here and plus here. So we will get CH3CH. So to this the H is attached. Okay, to this the H will be attached, and then to the benzyl carbocation we will have this one CH, then phenol group OH, and to this one we will have the Br group. Okay, so the correct answer for this question will be option number B. You can see CH3, CH2, CHBr, OH, that is option number B. Next, in the reaction you have to find, we have your terminal alkynes. Okay, and then when you take NaNH2, so it will form one, the terminal H will be removed, and we will get a nucleophilic condition like this, CH3, sorry, not CH3, CH. So it will behave as a nucleophile now. Okay, C minus is there. Now it will attack, so this is X. Now when you react it with CH3I, okay, so this one will attack on this one, and we will get CH3. Okay, now when you do H2O2 Hg2 plus, okay, so that is your addition of mercury. So what will happen, water gets added, so we will get CH, then here it will be double bond OH, and here H, and then CH3. Now what happens here, there will be tautomerization, right? So we will get here CH3, C double bond O, and then we will get CH3 on the right hand side. So this is your acetone. Correct answer for this question will be option number C. Okay. Next question, from the following compounds choose the one which is not aromatic. So here you should know this one is a very famous example. So when this molecule is there, option number B, it actually exists in this form. Okay, and all the carbons are not in the same plane. So for aromatic the condition should be all the carbons should be in the planar ring, but that is not possible in this one due to these hydrogens present. So correct answer for this question will be option number B. Next, similar to alkenes and alkynes, benzene also undergo ozonolysis. In the sequence of the given reaction, identify X and Y. So first of all, what happens when you add only O3, ozonide is formed, and after that it breaks, right? So what will be the final product? If you see, we have benzene like this. Okay, so all the double bonds will break. So this one will break, this one will break, and this one will break. Now on where you are breaking it, there you have to add oxygen. So if I want to write like this, so here we have hydrogens. Okay, so now we can just write, so all the products will be same, right? So now what if I want to write the first product, you can see here this line is there. Okay, 1 second. Okay, so now if you see here, this bond is there. Okay, and then we have this side, these two, and here double bond, and this side hydrogen is there. Okay, and next this side is also like this, and this hydrogen is there, right? Now if you see, this is called as glyoxal. Okay, so now three such from here, and from here we'll get 3 types of glyoxal, and there will be a triozonide. So correct answer is option number A. Next, which of the following reaction is expected to readily give a hydrocarbon product in good yield? So if you see the first one, that is your halogenation in presence of HNu, it can give you primary, secondary and tertiary halide. So it is not a good method. This one, if you see, it will produce your alkene because tertiary alkyl halide is there. Electrolysis will give you the product correctly, the haloalkanes. We want the hydrocarbon, whichever we want can be produced from here, and this one will form esters. Okay, so the correct answer for this question will be option number C. Okay, next, which among the following is the most strained cycloalkane? So we know cyclopropane has the angular strain maximum, so it is a strained molecule, so correct answer will be option number C. Next, a reagent used to test the unsaturation in alkenes is. So you know bromine has the color of the bromine, or bromine decolorizes when it reacts with an alkene. So that is why we can use bromine as a test for unsaturation. So correct answer is option number C. Okay, so you can remember decolorization of bromine happens. Decolorization of bromine water. Okay, decolorization of bromine water takes place when it reacts with your unsaturated hydrocarbons. Next, methane can be converted to ethane by the following reaction. Chlorination followed by alcoholic KOH. So that will not be any reaction. Chlorination followed by aqueous KOH, that will give you methanol. Chlorination followed by Woods reaction. So if you have CH3Cl, that is chlorination, and then if you do Woods reaction, okay, then we will get CH3CH3. Okay, so methane can be converted to ethane using this process. Correct answer will be option number C. Next, which of the following is the most stable alkene? So for stable alkene, you know, more substituted alkenes will be more stable due to the number of hyperconjugation structures. So more substituted means around this double bond, if you have more number of carbons, right, they are more substituted. So if you see in the first one, here there is R, okay, only one carbon is there, and here H, and here H. Now if you see second option, all the four are hydrogen. Third option, you can see 2R is there, but in the fourth option you can see all the groups are substituted. So that will be more stable. Correct answer is option number D. Okay. Next, which chlorine is, when chlorine is passed through boiling toluene we get. So we have toluene, okay, and when you pass chlorine gas, so what will happen? It will not react with the benzene ring, because for that we need a Lewis acid. Here what happens? Here it can replace the aliphatic carbon and we will get here CH2Cl. Okay, and this is your benzyl chloride. Correct answer is option number D. Next, 1 mole of a symmetrical alkene on ozonolysis gives 2 moles of an aldehyde having a molecular mass of 44 U. The alkene is. So first of all, the question is given symmetrical alkene. Symmetrical alkene means around the double bond both the groups should be same. So ethene is a symmetrical alkene, propene is not a symmetrical alkene, and 1-butene is also not a symmetrical alkene. But-2-ene is again a symmetrical alkene. So if you see the product of ethene, okay, and it undergoes ozonolysis, right, this bond will break and we will get this one, that is your methanol. So what is the molecular mass of this one? If you see 12 carbon, this is 16 and then 2, right? So we will have 30, but the mass given is 44U. Then let us try with but-2-ene. Okay, so this is but-2-ene. Now this bond will break, so I will get here CH3, CH and double bond O. So if I will draw this structure, we'll get CH3, C double bond OH. So we have 2 carbons, so that is 24. Then we have 16, 1 oxygen and 4, right? So we will have, that is 44, right? So that is what is given in the question. So correct answer will be but-2-ene. Okay. Next one, iodine value is used to determine degree of unsaturation, right? So like bromine water, iodine can also react with unsaturation. So correct answer will be option number B, and we can tell how much unsaturation is present in any compound based on how many iodine has been consumed. Okay. Now next, which one of the following is the most energetic conformation of cyclohexane? So if you remember, cyclohexane structures is like this. Okay. So here it is A, B, C, D, again C, B and A. So what is A? Okay, A is your chair conformation. Okay, B is half chair. Okay, and then C is twisted boat. Okay, and D is boat configuration. So you can see this is the highest energy, that is your half chair. So correct answer for this question is option number D. Next, identify the main product in the reaction. So you have tertiary halides, tertiary alcohols, right? So what will happen in H3PO4? It will undergo dehydration, right? So here we can get a double bond. So now if you see, this is 2-methyl propene, right? So the answer will be CH3, CH3 whole to double bond CH2, that is option number A. Now let us see the next question. The compound which on ozonolysis produce a mixture of propanol and ethanol. So when the product is given, so just write both the products in such a way that the oxygens are like in front of each other. Then remove the oxygen and connect them with a double bond. So now if you see propanol structure, I'll write like this. And one more is ethanol. So this is ethanol, right? Now what we can do is just remove the double bond oxygens here and then connect it with double bond. Okay. So now if you see 1, 2, 3 and 4. 4 carbon, and on the second carbon we have a substituent. So 2-methyl-but-2-ene. Correct answer is option number D. Next question. When 2-bromopentane is heated with alcoholic solution of potassium hydroxide, the major product is 2-bromopentane. Okay. So we have this one. Okay. When 2-bromopentane is heated with alcoholic QH. Okay. So now you see there will be elimination reaction, but there can be 2 elimination, like this HBr can also go and this HBr can also go, but we have to produce more substituted alkene, or that is your Setzeff rule. So this bond will form. So I'll get 1, 2, 3, 4, 5 pen-2-YNE. Correct answer is option number D. Okay, next. Which of the following chemical system is non-aromatic? So you know, for non-aromatic there should be sp3 carbon. In option A, all the carbons are sp2. In option B, all the carbons are sp2. In option 3, there is conjugation. If you can see, sulfur has lone pair, which is under conjugation. In option number D, if you see, this carbon is sp3, right? So it is not a planar molecule, so conjugation cannot take place. So correct answer for this question will be option number D. Next, in the following reaction, okay, you have to find the P will not give. Okay, so if you see here, what I'll get here. First, when you add water, we will get on one carbon OH and on another carbon H. Now what will happen? This one will react here. So we will get HC double bond O and then CH3. Okay. Now if you see, this is one aldehyde, that is your ethanol. So now ethanol can give you tolerance test because aldehydes. Brady's reagent is reaction with 2,4-DNP. That is also correct. Victor-Meyer test is given by alcohols, right? But this is an aldehyde, so this one will not produce. And iodoform reaction, you can say CH3CO group is there, methyl ketone group is there. So that one will also react. So correct answer will be option number C. Next, the organic compound obtained during the addition of HBr to propene in the presence of peroxide is. So if we have here propene, okay, and HBr with peroxide. So it will follow anti-Markovnikov's rule. Br will come here and H will come here. So that is 1-bromopropane. Correct answer is option number C. Next, Markovnikov rule is applicable to. So you have to remember, Markovnikov rule is only applicable when there is unsymmetrical alkenes. Okay. Unsymmetrical alkenes and HBr should be there. Now, if you see C2H4 and C2H4, that is your ethene are symmetrical alkenes, so we can eliminate these two, HBr or HCl like that. Okay. Now, if you see C3H6 with HBr, so if I have C3H6, 1, 2, 3, 4, 5 and 6. Okay. Now, if this one is reacting and we are getting HBr, then what will happen? Markovnikov's rule, Br will go to the carbon having less number of hydrogen and this one will go to here, right? So that is why it is applicable here. Correct answer is option number A. Next, if you see CH3CN, okay, and then if you dilute HCl, then what will happen? It will get hydrolyzed and we will get CH3, C double bond OH. Now with lithium aluminium hydride, this will reduce to one alcohol. So we'll get CH3, CH2, OH. Then, so that is your A. this is A, okay, and then this is B, and then you will get with PCl5 you will get CH3, CH2, Cl. Then if you do alcoholic KOH, then what happen? H and Cl will be removed and we will get ethene molecule. Okay, so correct answer for this question will be option number B. Next, which of the following is aromatic? So you know tyrosine, you have to remember tyrosine amino acid is aromatic in nature. Correct answer is option number D. Next, isopropyl chloride and isobutyl chloride reacts with sodium in ether to give. So this is your Woods reaction. So isopropyl chloride structure, if you remember, this is isopropyl chloride. Now isobutyl chloride, if you see, isobutyl chloride is like this, right? So I can draw that one here, Cl, then C, and then this one, right? So what will happen? This two will go and this two will connect. So we will get this one, C, C, and then C, right? So 1, 2, 3, 4, 5. So 2 and 4 dimethyl pentane. So correct answer is option number D. Next, bond length of the following. So ethane is their single bond, right? So it will be the largest one. Then ethene, then acetylene and benzene. So benzene has a partial double bond, like it's the bond order lies between single bond and double bond. So after single bond there will be benzene, okay, and then we will have ethene because double bond, and then last will be your the last one will be ethyne molecule. So what is the number for ethyne molecule? Acetylene is 3, right? So we will get 1, 4, 2, 3. Okay, correct answer is option number C. Next, which of the following compounds show dipole moment? Okay, so 1,4-dichlorobenzene, if you see, this is the structure, right? The net dipole moment will be 0. So this is doesn't show dipole moment. 1, 2, if you see, yeah, this one will show, right? 1, 2 will have a net dipole moment. Now trans dichloroethene, if you see, so if we have this one, trans dichloroethene, this one will also get cancelled. But2-ene trans will also cancel because they are in opposite direction and equal in magnitude. So the correct answer for this question will be option number B. Okay. Okay, so these were the top 30 questions from the hydrocarbons chapter. So prepare similar questions. It is very scoring topic. So like if you are able to solve these questions, you can assure these chapters are almost ready for you. So if you have found this video helpful, please like, share and subscribe the channel. There are many upcoming videos for your COMEDK preparation. So thank you for watching and all the very best for your exam.